progress in biosciences is driven by visualization technologies that reveal biological processes at the cellular and molecular levels. Confocal imaging has evolved into a key platform for advancing from basic observation to quantitative analysis of intricate cellular mechanisms. Here, we introduce QUADSCAN, a next-generation imaging platform designed for advanced bioscience research. Ultra-fast scanning, high-sensitivity detector, 4-channel simultaneous real-time imaging, single pinhole confocal microscope. Conventional confocal microscopy faces significant limitations in multi-channel and real-time imaging. Multi-protein visualization requires sequential wavelength acquisition, and limited scanning speeds substantially compromise the efficiency and reliability of multicolor imaging. QUADSCAN overcomes this issue with its independent subunit module. Each subunit module integrates independent laser sources, pinholes, and detectors for individual wavelengths, physically eliminating inter-channel crosstalk and enabling simultaneous, real-time acquisition across 4 channels. A 29 kHz resonant MEMS mirror achieves acquisition speeds of up to 76 frames per second, enabling real-time visualization of dynamic cellular processes. High quantum efficiency gas PMT detectors deliver exceptional sensitivity, enabling precise detection of extremely weak fluorescent signals with minimal noise. The integrated stage-top incubator, anti-vibration table, and real-time autofocus AFS ensure stable conditions for long-term live cell imaging. Furthermore, acquired data can be analyzed using QuadView software, enabling advanced 4D visualization and comprehensive processing. QUADSCAN enables rapid 3D imaging of various cleared organs with 4-color multi-antigen detection, opening new frontiers in biological research. No more slow. No more high costs. The synergistic integration of resonant MEMS mirror scanning and Gauss PMT detection enables exceptional temporal resolution and sensitivity for high-end biological research. QUADSCAN.